Hello, everyone. Thank you, organizers. It is really a pleasure to be here today. My name is Africa Periañez, and I'm the CEO and founder of benshi.ai. benshi.ai is a nonprofit funded during the pandemic, together with the Bill and Melinda Gates Foundation, to bring the latest personalization techniques to the most underserved communities. We are building a machine learning platform to provide with individual recommendations, with individual predictions and incentives to healthcare teams and patients. So our vision is accelerating and democratizing behavioral machine learning for low and middle income countries to reduce health inequalities. More specifically, we focus on providing real-time and just-in-time personalized incentives and recommendations to frontline health workers and patients, and use this data to move from individual to collective to shape strategies for collective behaviors and help in this way healthcare leaders. We have many challenges, but here we prioritize the ones that we focus the most, we can say. So we want to operationalize those large scales digital traces from mobile health devices and be able to turn those behavioral logs into robust, personalized results and move towards causal analysis beyond correlations. How we are doing this? Here in this slide, I show a schema about how we connect with our partners. So first, we receive those data, those logs of the different apps, either patient data or healthcare logs that they are using during the app. And we combine those logs with different contextual information. And then with this information, we apply different machine learning models and experimentations to be able to find what is going to happen next and how we can incentivize, how we can nudge behavior. And the reaction, the impact we are having is feedback into the system. Who is behind benshi.ai? We are a team of data scientists, of engineers, data visualization designers, and strategists, healthcare specialists that we are working restless to put this forward. We are a diverse team. This is crucial for every data science team, but particularly for this project, sorry, is essential. So So we need to be able we need to be able that our models generalize properly. This is why it's important that we have engineers and data scientists coming from many different cultures, many different backgrounds, to be able to that this reflects in the models that we put in production. So myself and most of the leadership team are coming from the same background, are coming from the video game industry. And why I'm mentioning this at all? Why is related video games with healthcare? So in probably is in most of the, we can say that probably video games is the industry that knows better how to motivate, how to nudge behavior. And most of the successful apps, they have game design principles into the app design. So I'm talking moving beyond gamification. I'm talking about game design principles like intrinsic motivation, like retention, or well fine-tuning of complexity, of difficulty to engage, to progress into the app with new content, with new features. So this kind of technique and this kind of knowledge and how to motivate is something that is being applied in many places. And at the end, this is what we want to do. We want to be able to definitely engage with the right level of engagement to the different users, to the care teams, to the patients, with the goal of improve different healthcare outcomes. So this is what we want to find. What are the key elements that they are going to motivate and to improve the healthcare outcomes that every app, they have different ones and be able to succeed and make those apps really strong. Here I'm showing one schema about how we interact, how we communicate with our partners, And in this slide, I mainly want to highlight that there is a first component of communication that is the front-end dashboard, where our partners have full transparency, full knowledge of which models are in production, which transformation or functions are applying into the data, which models are in production, and when we have changed the version, what is the accuracy, what is the different features that are feeding those models. All this information is available into a dashboard that I will show later. And then the second way of communication is through API and SDK directly with the end user. Here I want to talk about one of our partners, that is Maternity Foundation. So Maternity Foundation has developed an app, Safe Delivery app, which is an online learning app to improve skilled birth attendant training and support. But before moving from tech to midwives, I want to talk a bit about midwives indeed. So midwives save lives. So a well-trained midwife is able to almost reduce the mortality of mothers and the neonatal mortality up to 2/3 if the midwife is well trained. So the impact that organizations as the Maternity Foundation are having in saving life is crucial, because they focus on improving the learning skills of midwives around the world, mainly in low-income settings. So, and this is how we are working with them. We are working with them towards a personalization and we create an adaptive learning journey with the right content, with the right recommendations at the right time to help them into their work, to help them to continue learning with the right information for everyone at the right pace. Here, I'm showing you some data from users in Ethiopia. So here we can see on the right that we have some predictions on learning progress among the users of this app. So we can see that there is a change of behavior for those users, that uh, mm, they are able to progress beyond level 5. Okay. And we observe that even if most of the users are not able to progress beyond that level, if they do, mainly are midwife or physicians. And also here we are showing predicted progression level versus predicted connection time. So we observe, and this makes a lot of sense, but it's something that this is why it's important to continue engaging them, is that predicted progress typically increase with predicted connection time. And most of the users that are able to progress above level 5 will spend at least 3 hours using the app. So the fact that they engage in the app, that they enjoy using the app, it made them, that's made them to learn more and at the end save lives. So this is just an example to the kind of partners with whom we are working, the kind of app that we are integrating. I come back here to the system schema, to the infrastructure. Here in this slide, I just want to show a very high level view of the infrastructure. So our backend is hosted in a Kubernetes cluster. We are using Databricks for our data pipelines and model training, and MLflow for model management system. And here I'm showing some of the products that we have incorporated that are in production. And here we can observe the full cycle since data ingestion until the action and the implementation of the different incentives. So first of all, we have the data ingestion product, where our partners can come and in a self-serving way, they can upload the schema, define the different projects they have, and they have different KPIs to see how the ingestion is going. And from the core data structure point, this is where we all the data from all the different partners have the same aggregation, the same kind of well, not the same aggregation because it depends from partner to partner, but the same they're uniform. So from there, I want to highlight, and we have different data pipeline and processing for the different metrics, KPIs, and features. Okay, but the point in the point four, I want to highlight these three pillars that are very important. This is uh, the different ways that we treat the data at the end. So one is analytics. Okay, this is we focus on path information. First, this information is used to mainly for validation and metric monitoring purposes, but also to provide to our partners actionable insights of information that happened in the past that can be useful for them. That we realize that is already useful information that not so many partners have already analyzed deeply. And the most important ones are predictions and recommendations. These are the machine learning models that we have in production. The first one tell us who is going to suffer what in the future, who is going to suffer a disease, who is going to disengage of the app, and when this is going to happen. But okay, we can predict this, and then what we do with this information. And then we have the machine learning models with the recommendation system that based on data tell us what is the most likely incentive that is going to work with every individual, with every person at the right stage that we want to nudge them. Okay. Once we have the what, we apply this directly? Of course not, because our mission is to to democratize experimentation at the end. That we need to assure the impact that our hypothesis, that our predictions are having, and the only way of doing it is through experimentation. And then this is why we have built the experimentation engine. And now we have all the material, all the information, all the randomizations of different ways ready to be used. And where this becomes reality is in the action registration, what we call nudging space. And this is where we expose the API and we send this information to every user at the right moment. So here in this slide, I also want to show how we are keeping track, keeping full control of the machine learning models that we put into production. Okay, we really need to have a very good model governance. Okay, and we are doing this, taking control of two main pillars. The first one is the code, all related with the type of algorithm we are using, the type of parameters, any change on the we can say on the filters that we use, or any change in any, as I said, any parameter is going to keep track here. It's going to be a different version or a different model, okay, depending on the degree of the changes. And then we have the control in terms of the data, okay, which data is being introduced to train those models. If we are taking more time frames, or if there is any bias removal that has been applied, all this information is going to be separately to the type of algorithm of any change into the model parameters or features is separated for the type of data that we are putting in, and we have full control of every single change that can make a different impact and visualize also in the platform. I also wanted to talk about data pipeline development. So we also have developed DBX2, okay, that is of course based on DBX, that developed by Databricks. And what we have done here is that, well, we started using DBX indeed before it was open sourced by Databricks. It was last November. And what we have done is we have added other in-house customizations to fit different development needs. Okay, so for instance, we have added um, data connectors to different data sources, or we have changed the configuration file from JSON to YAML. So this we also use it because it is very important for us to work. I mean, to work in local, okay, for good coding practices, and also the power of using Databricks for manipulating and easy access of data into the cloud. Here, I go a bit on detail of what I talked before, and I added one more block that I didn't mention in the schema I was mentioning before about the machine learning models. So we are using, as I said, prediction behavioral models to predict who is going to suffer what when, okay, to predict actions, who is going to connect when, what is the kind of content they are going to consume, when they are going to disengage in terms of the time of the app, in terms of actual time, in terms of progression into the app, or for instance, yeah, so predict the location, okay. At the end, what we are defining here is the sample of my experiment, okay. And the second block is the recommendation. So which action makes more sense for everyone at a different stage of their life using the app, of the different event they are going to suffer, to recommend, okay, based on the data. So all this information is in our is provided by the recommendation system. And then we have a third block that you mentioned before, that it was the contextual factors for casting. Contextual information is crucial for our recommendations. So it is not the same if we are if we are giving a recommendation into, for instance, to a midwife during dry rainy season, or if there is a particular epidemiological outbreak or a different event that is happening into that area. So this information contextual information needs to be updated. So this is why in many cases, this information, it is not updated. So then we need to work with projections or with forecasts to be able to have this information available to support the recommendations based on the behavioral logs. Then it's also important that in some cases, because maybe ethical reasons, we cannot perform experiments. Okay, so in those cases, we will also provide with a set of tools to perform observational studies. Okay, to try to inference as much as we can what is the impact of different interventions into the metric of interest. And also, of course, we incorporated, and this is crucial for this kind of machine learning platform, a full analysis of the impact of the experiments or actions we are taking, or the validation of the machine learning models in production. And now I want to briefly mention a bit deeper into the experimentation engine we are building, and this is why I added this sentence of the way. I'm sure everyone knows the importance, and mainly nowadays, of experimentation of clinical trials. But well, just to mention and to remark this importance. If a scientific woman be asked what is the truth, she will reply that which is accepted upon adequate evidence. And if she's asked about the description of adequacy of evidence, she will certainly refer to matters to observation and experiment. And to throw these considerations would means throw away the key of understanding knowledge and its object. If we really want to know the impact and how it's affecting any action we take, we need to perform an experiment. And this is why it's crucial to implement these kind of technologies and bring the latest state of the art in terms of experimentation to the most underserved settings. So we are implementing in our platform A/B testing, of course, basic and moving into micro-randomized trials, bandits and contextual bandits. More specifically, MRTs, micro-randomized trials, involve multiple randomizations and enable causal modeling of proximal effects of the randomized intervention component. So at the end, what we want to evaluate is when and for whom these interventions are effective and which kind of factors are maximizing or reducing the impact of those interventions. So in terms of contextual bandit settings, it's a system that is learning the optimal decision and is able to adapt on the fly, depending on the user, depending on the patient, depending on the healthcare worker. And at the end, contextual bandits is connecting, let's say, more classical experimentation to really continuously adaptive systems providing personalized and contextualized, very important, online contextualized interventions. And here, as I mentioned before, I just wanted to show you how, what is the aspect and how it looks, the machine learning platform we are building. So here we are constantly implementing new features, new services, and new products. Here is the landing page where we can see different KPIs and where just the status of different actions. Here is the data ingestion product, different schemas, how the ingestion is going. So model management, the models that are in productions, the different versions running, different features incorporated, and the validation for every type of model, every class of model. We have different validations that they are showing, like IBS there, or C-index, or scatter plots. Here we have a summary of the different experiments we are testing and the impact we can see monitoring that is having. So here we can see the average behavior, if it's having an impact of different metrics. And here we can observe different individual users, how they behave compared to the average. And at the end, if the experiment was significant or not. If you want to create an experiment, it's easy to do, etc. Okay, just very quickly to show you how does it look. And well, just to finalize, so our goal is to boost health outcomes in resource-poor countries through personalized incentives to nudge behavior. And to do that, we are building a machine learning platform focusing on individual behavioral predictions, recommendations, and reinforcement learning-based experimentation. So, and the last step I want to say is that we at the end, our vision is to democratize behavioral machine learning. And right now we are exposing APIs, but we want to move forward to develop SDKs to fully integrate with the different apps and to make it easy to that every app in low-income settings is using it. Thank you very much for your attention. And well, just to mention that we are hiring. So we are hiring engineers, data scientists. So if you're interested in joining us or to collaborate with us, please let us know. Thank you very much.